Morning. Today we are going to start with fuel cells. So our model is energy systems. Energy systems is divided into three parts. They are chemical fuels, fuel cells and solar energy. So in chemical fuels we have discussed what are different types of fuels, classification of fuels, definition of fuels and fossil fuels, knocking, right, and biodiesel. So now, next we are going to discuss about alternate source of fuels. In chemical fuels itself, we have discussed the alternate for fossil fuels. The main alternate was for alcohol and biodiesel, isn't it? So now let us discuss another alternate for fossil fuels. Those are fuel cells. So what are fuel cells? So fuel cells are also a type of galvanic cells where electrical energy is directly obtained. Electrical energy is directly obtained by combustion of chemical fuels which are supplied continuously. So I repeat, fuel cells are also galvanic cells where electrical energy is directly obtained by continuous supply of chemical fuels. So here the fuel cells will act as only the reaction chamber. So if this is the fuel cell, consider this as a fuel cell. So at one side we are going to this will be the anodic chamber, this side will be the cathodic chamber. But the anodic chamber we are going to supply the reaction side. This is the anodic reaction side and this is the cathodic reaction side. At anodic reaction side we are going to supply the anodic reactant. At cathodic side we are going to supply the cathodic reactant side. So here the reaction occurs and energy will be produced. Okay, so here reactants will not be saved. Okay, unlike the batteries, the reactants will not be saved. The chemical energy will not be saved, but it will be supplied continuously. It will be supplied through the inlet. It will be supplied continuously through the reaction chamber. Okay, so these fuels will be saved. The reactants will be saved separately under specified temperature and specified pressure. So the main thing here is these reactions are also redox reactions. Reactions which occur in the fuel cells are redox reactions, and the products which come out of the fuel cell are eco-friendly. It is usually carbon dioxide and also water. Okay, so carbon dioxide is not a pollutant and water is also not a pollutant. So let us see what reactions occurs at anode and cathode. So at anode, so when you supply the fuel, as I told you, this is the fuel cell. This part will be the anodic reactant and this will be the cathodic side. So here we are going to supply the full fuel here. So what will happen? Oxidation occurs at the anode, electrons will be liberated. And this is the cathodic side. So here what will happen when you are supplying the fuel here, the fuel undergo, it is oxidant. So it will undergo reduction here. The oxidant will get reduced by accepting the electrons and the reduced product will be obtained. Okay, so supplying fuel here at the anodic side, the fuel undergoes oxidation, liberating electrons as shown here. Okay, at cathodic, you are going to supply the cathodic reactant. So here the oxidant will accept the electrons is liberated by the anodic side, undergo reduction and form a product. So these few products will be removed continuously. These products will be removed continuously. So normally formed products in the fuel cells are water and carbon dioxide. So carbon dioxide will escape into the atmosphere and water, so it will be in the form of steam, can be liquefied. So fuel cells are not harmful and moreover it will not store any of the chemical energy in it. So let us see how these fuel cells are differ from battery. So you might have a question, sir, how fuel cell differs from a battery? Our fuel cell and batteries are same. We know very well about batteries. Are fuel cells and batteries same or do they differ? So there is a simple question. I'll just give you the differences between batteries and fuel cells here. Okay, we'll just see what are batteries. So what is a battery? Can you understand what is a battery? So battery is a energy storage device. When two or more galvanic cells combine together to form a battery. Whereas your fuel cell is a energy conversion device. As I told, you will be supplying the anodic reactant and cathodic reactant to the fuel cell. So there redox reaction occurs and energy will be liberated. So until you are supplying the chemical fuels to the fuel chamber, fuel cell, you can withdraw the electric current. Once you stop, you can no more withdraw the electric power. But in batteries, it's not like that. The chemical energy will be stored, okay, and it will be converted into electrical energy. So it will produce, batteries produces electrical energy until active species are present, as I told you. Whereas your fuel cells, until we are supplying the active species, we can withdraw. The recharging can be done. For batteries, you can recharge. You have two types of batteries, right? You have primary batteries, secondary batteries, and reserve batteries. We'll discuss that in near future. But batteries can be recharged. The secondary batteries can be recharged. Whereas in your fuel cells cannot be recharged. Okay, recharge cannot be done. So the reactants and products will form integral parts of battery. You can never see the fumes coming out. You have different types. You have lead acid battery, nickel metal hydride battery, lithium cadmium, nickel cadmium battery, lithium ion battery. You have different types of batteries. The list goes on, right? So the reaction occurs and I have never seen the product coming out, right? So the reactants and the products will form integral part of battery. Whereas your fuel cell, neither the reactant nor the product will form the integral part. So reactant will be supplying continuously to the batteries, whereas the products will be continuously withdrawn from the fuel cell. This is the major difference. So the active materials are mixtures of chemical composition, where active materials means the reactants. So here in fuel cell, the active materials are fuel and the oxidant. Your batteries, the products might be hazardous, whereas here in fuel cells, the products are eco-friendly. So as already discussed, recharging can be done in batteries, but in fuel cells, recharging cannot be done. So the electrodes are cheaper in case of batteries, whereas in fuel cells, the electrodes are very costly. So in batteries, catalysts are not used. So redox reactions occurs. But in fuel cells, catalysts are used to absorb the gases which are released. So the maximum voltage is produced in case of batteries, whereas the voltage produced in the case of fuel cells are less compared to batteries. Of course, the efficiency is more, but the voltage produced in case of fuel cell is lesser compared to batteries. So these are the major differences between batteries and fuel cell. So in case of batteries, the examples, as I told you, it goes on. Nickel cadmium, zinc air battery, zinc manganese oxide battery, lithium ion, lithium manganese oxide, nickel metal hydride, nickel cadmium. It goes on and on. So I similarly have different types of fuel cells. Okay, I have methanol, oxygen fuel cell, methanol, hydrogen, oxygen fuel cells, solid oxide fuel cells. In solid oxide fuel cells, again you have different types of fuel cells. Again you have acid fuel cells, you have alkaline fuel cells. Again you have different types of fuel cells. Again in case of fuel cells. So you have different types of fuel cells even in fuel cells. So these are the examples. Okay, so we have discussed the differences between batteries and fuel cells. Let us see what are the advantages of fuel cells. The major advantage of fuel cell is the power output of fuel cell is high, right? The power output is high and charging is not required. So we know that the fuel cell, if we want also, the fuel cell cannot be charged. So recharging cannot be done and charging is not required. So the maintenance cost is less and the maintenance is less. Other major advantages, it emits less pollutants. Of course, whatever the output, the products are coming, it is eco-friendly also. So let us see if there are some advantages. Obviously, it will have some disadvantages too. So let us see what are the disadvantages of fuel cells also. So fuel cells have some limitations. So fuel cells produce energy as long as the fuel and oxidant are supplied, because it will act as, the fuel cell act as a energy conversion device, right? So therefore the fuel Cells produce energy as long as fuels and oxidants are supplied. So the electrodes used in fuel cells are very costly. Other major thing is the fuel, that is the oxidant, should be stored separately, because the fuel cell is a conversion device. The fuel should be supplied separately, right? So it should be stored in a separate tank under high pressure. That is again a challenging task, right? So that is another major disadvantage or limitation. So reactions are constantly reactions should be reactants are constantly supplied, and the products are constantly removed from the cell. So if you're removing is becoming if you're not removing the products continuously, again the performance of the fuel cell also will be decreased. So these are the advantages and disadvantages or limitations, so called limitations of the fuel cells. So in our next discussion, we'll see the construction and working of different types of fuel cells. Thank you.